We are honored to hear from our two team members over here to my left. I first would like to introduce Glenn Finch. Glenn is the General Manager and Global Leader of Cognitive Business Decision Support at IBM. Glenn's emphasis on process reimagination, cognitive and analytics, come on now. He combines all of this work across the Watson IoT health, data, and weather business. So thank you for joining us today, Glenn.
Sure.
All right, fantastic. And with Glenn today is Ngozi Onwuaduegbo. She is a senior managing consultant and global leader of cognitive business decision support as well. She leads the global strategic initiatives and develops AI solutions such as IBM's content intelligence for discovery and insights. So, welcome,
over to us.
Welcome our friends from IBM.
Good, thanks. So guys, we're going to have some fun with you today, talking a little bit about how to make cognitive AI, data, and all that stuff very, very practical. How many of you have cell phones with you? Okay, take them out, put them on the table. You're going to need them later because we're going to immerse you and we're going to digitize some things together. Okay, because I'm figuring it's afternoon, you had lunch, you're like, oh my God, would this guy finish so I can get to sleep? I promise you we're gonna have some fun with you, okay? So what we'll do is we're gonna talk to you a little bit about the cognitive enterprise, which is something that we've kind of gotten to in IBM as a way to help clients figure out all of the moving parts, because it's so easy to chase after a thing. Then the thing makes you very, very happy because you've done the thing. And usually to get the thing done, there's 3 or 4 other things that have to happen. Probably the hardest thing right now is not the thing itself, but how to change ourselves so we can deal with the thing. And we're going to talk about that just really, really quick. So Ngozi, talk a little bit about the challenges these guys might face. I know they already know their challenges, right?
Yes, absolutely. So we deal with clients across different industries and clients that do the same work that you do, and they face challenges as far as getting the most out of their data. And we've kind of bucketed them into 4 categories that I'll just breeze through, right? The first is around IT infrastructure. How do you set the foundational principles of IT to get data that you need, right? I know you guys work in third world countries where there's no network and no connectivity, and so that fundamental requirement is missing, right? The second challenge is around a skills gap and the widening skills gap, right? Not having enough SMEs that know how to use the data, how to work with the data to get the most out of it. The third challenge is keeping up with the ever-changing data requirements, right? GDPR, for example. How do you use data? How do you collect data? You work with countries, right, that have different requirements. So how do you keep up with that and make sure you're compliant and getting the most out of your data?
That was the big conversation from the panel just a few minutes ago, right? Is how do you protect yourself and do good without doing harm, right?
Right, and it's changing. It's going to keep changing, right? And then the fourth bucket is around manual data extraction, right? Spending hours extracting data that is locked in the document, not having resources focused on value-add activities, but just doing that manual extraction. And that will be error-prone, right? Imagine getting requests or orders for clinical data in piles of boxes. Not really value-added, right? But IBM has a perspective on how we can use technologies to solve these problems, and Glenn's going to talk about that.
Awesome. So the cognitive enterprise, like a little layer cake. By the way, can you guys in the back see the slide? You guys okay back there? Yeah? Because there's going to be a test later on. No, it's back there? Yeah? Good. Let me look. You move there for me, thanks. A trip and fall. Okay, you can see it. And Ngozi, it actually looks good on the monitors back here. So anyway, 7 layers, right? And in each one of these layers, remember I said we tend to focus on things. Usually somebody starts in a layer, and they go headlong in one of the layers, and they kind of forget the other 7 layers. Now, I'm not going to drill through all 7 of the layers, because that would feel like a standard IBM architecture presentation, and then you would be asleep, right? But at the very top, this whole thing about people and culture and skills. it's the hardest thing. I don't know whether you guys face this, but we do a lot with robotics process automation. Anybody else, you know what I'm talking about, the little software robots that do tasks? Yeah? You guys good? Yeah? So for whatever reason, when a robot does something for you, you say, okay, somebody's doing something for me. I can get my head around that. There is some strange thing culturally that when a machine tells you what to do, maybe it doesn't happen to you. But one of the things we find in all of our clients around the globe is that the people where the machine tells them what to do, they want to just take a bat and beat the machine. It's like, I won't tell you the profanities that happen, right? But think about that when it comes to change it, and even think about that in some of the, I work in some of the countries that you all work in. So there is this profound experience, right? And we have to make it so easy and so believable, much like Apple has done with their phones. So my 85-year-old father-in-law, Ed Joyner, former police captain, if something doesn't work, he will just run it over. That kind of guy, right? We gave him an iPad, took it out of the box, he knew exactly what to do, right? So along with this culture, you have to have this human design so that it just feels very, very natural that things happen. Now, the next layer, I'm not going to talk about platforms too much because that's usually for folks that want to make a business out of organizing and orchestrating like 70 unique AI things, and they're going to say, okay, we're going to be the next Uber, or we're going to be the next water company, or we're going to be whatever, right? We're going to be Waymo, or pick any of those platform companies, right? I'm not going to spend a lot of time there. What Ngozi and I are going to spend a little bit of time with you in these next three layers. Data, which, by the way, 80% of all the world's data is locked either in the files that Ngozi talked about, or it's sitting behind some firewall. Nobody can see it. We've come up with this way to kind of expose that, fully secure, to all these wicked, cool technological buzzwords. Machine learning, AI, computer vision. We're going to spend most of the time on computer vision today. 5G, edge, blockchain, blah, 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 right? The list, because we're IBM, that list could like tip over, and that's all we spend time on. Take the data, expose it to that, and make a new intelligent workflow. That's what we're going to talk about today, right? And then, by the way, some of the layers below about next generations and secured, hybrid, multi-cloud, if you ever want to really dig deep into that, I'm happy to spend as much time with you on that. We're not going to do that today. But the issue with data in third world countries, leaving the data where it is, playing it right there, and then dealing with it across a cloud, if you care about doing all that stuff, we feel very, very comfortable about that. So we have the cognitive enterprise. We have maturity models. We have all these things. I'm done talking about the cognitive enterprise. What we want to do is we want you to be immersed in what this thing feels like, right? So phones out. Everybody got phones out? Okay, good. On your tables are these, at the edges, where you can't reach them, I promise, are these pay stubs, okay? I'll hand this to you guys, okay? So grab a pay stub, grab your phone, and Ngozi's going to take you through this fun little exercise, okay? You want me to hand them to you? You good? Okay. You guys might have to pass them down to each other. Here's some, thanks. Ngozi, up to you.
All right. Okay. Everybody have the pay stub? Okay. I was told not to move.
You
so
should have worn your Ronda Roadie Rockstar glasses today.
I totally should have. I'm just going to stand here because I don't want to get hit by the light. But anyway, so the story that is kind of like the backdrop for the exercise we're going to be doing is what we did for a U.S. mortgage financing company, right? How many of you have mortgages? Right, so understand mortgage companies get applications from people like you and I, people that work at employers that have pay stubs in different formats. And when you think about data, the multiple formats is an added layer of complexity, right? So this client came to IBM. They, by the way, process thousands of loan applications per day. And the longest step within their overall process is income verification. So they came to IBM and said, gosh, we need your help. We need your help to reduce the cycle time for loan origination from what used to take 7 weeks to 7 days. 7 weeks to 7 days. Pretty bold goal, right? But we took on the challenge. But they had a fundamental problem. They had no data for us to use to power the downstream process. And so we had to get a little creative. We had to reimagine a way that we could create data from cell phones and use AI to transform the data, standardize the data, so we can then power the downstream process that they need. So, you have the pay stubs in your hand, you have your phones. What I want you to do is, on the slide, I'm showing the link to a mocked up loan application database. So I'd like you to go to your phone browser and access ibm.biz/paystub and take a photo of the pay stub.
Now, one of the fun parts of doing these demos, this is our, I think the 6th continent or 5th continent we've done these in. You know, when you do live demos, there's always this funny thing that happens right now while you guys are doing the work where you say, I wonder if that live demo's actually going to work. And so I don't know if you know, if you saw the helter-skelter, hectic thing just before we stepped on stage where we actually couldn't connect the computer to the HDMI cable. So I have to tell you, that causes the muscles of your body to tighten up. So if you all could do just like a little cleansing breath with me to make sure it's all going to work, I'd appreciate it. And Ngozi, it looks like it's working brilliantly.
It is working. Woohoo! All right, so that was the first step, right? Getting the data from the pay stubs into a digital format. And let's see what those photos look like, right? Let me just pull a couple examples, and we can start to appreciate, you know, another layer of data complexity in
Looks
the
pretty
form
good, though.
of image resolution. This is a little crooked.
Yeah, but it's still pretty clear. It's not too bad.
Shadow,
Yeah.
but not too bad.
No fingers yet, right?
No
No
fingers.
selfies.
No selfies. One more photo. All right.
Oh, we got a coffee mug in that one. I like. Oh no, that's somebody's hand. Good, good, good. That's good.
Exactly. Let's do one more.
Oh, we got a whole arm, or maybe it's somebody's leg.
It looks like a leg. It does look like a leg. Oh my gosh. I mean, and we've done this so many times. People get excited and actually take selfies. Like,
Yeah.
We've seen faces in here.
Or they upload a picture of their children or family or something like that. We've probably done this for about 100,000 people around the world. Anyway, you start to have fun, but you realize some of the challenges, right? Because image recognition, computer vision, is harder when there's extraneous shadows, bad images, all that stuff. But, Ngozi, take us through this so that we can look and see what the results will be, okay?
Right. So using AI and machine learning technologies, we're able to take the photo that you just took, pass it through an engine, and then get the elements that the client needs for income verification. So what you see on the right-hand side is an example of the image you just took. And on the left-hand side, we're showing the different extracted elements, 32 in this case, that our clients need for income verification. So things like your name, your social security number, your taxes, your employer name, you know, etc. This is data that is now standardized that you can use to enable all the other processes for income verification. I'll show another example. Again, you see on the right-hand side, some of you would have had this format of the pay stub, which is very different from the first one that I showed. But really, the extracted elements are in the same standardized formats. I mean, it's such a great way to make some sense out of the different formats of data, so it's easy to work with. It is more accessible and easy to be integrated into downstream processes. Well, mortgage companies, financing, pay stubs, a little different from the environment that you're playing in, right? But there are some examples of how we can take this to do the work that you do, and Glenn's going to talk about this.
Awesome. So you're probably saying to yourself, Glenn and Ngozi, thank you so much for entertaining us for 7 to 8 minutes. We got to use our phones, got to get a little visceral, but you guys are clueless about the challenges we're facing in the field, right? I can see the eyes. I get it. In fact, by the way, the team that prepared us for this, I was the most prepared for any presentation anywhere about all the challenges that you face. It was awesome. The team is great. 7 times, Glenn, you don't seem to understand what it's like out in the field. So, look, the thing that I want to get through to you is this concept of computer vision, right? Because what's different, so for all of our adult lives, we dealt with this thing called OCR, optical character recognition, right? And the whole plan of OCR is you could have this page, and you see where the word radically is up there? You would tell the machine the GPS longitudinal and latitudinal coordinate to find the word radically, right? And if it moved by a certain amount, the machine couldn't read it. You were toast. Yep. See, the funny thing that's different now with artificial intelligence and machine vision is you don't have to tell the machine where anything is anymore. Just like your eye knows that's a word, the machine knows that's a word. That wicked, by the way, Ngozi, I love that picture on the right-hand side. The way the machine knows there's a picture on the right-hand side is the same way your eye knows. So all you have to do is train the machine about the types of things that it needs to look for, and it will find them. So you say to yourself, Glenn, that's great. Well, so let me give a couple quick examples, right? So you heard about the big mortgage lender. There's another company called ADP that processes payroll, right? Everybody know the company? Yeah? So to make a new payroll customer, they have 1,800 people in a room about 3 times this size. And so help me God, they're like, they're keying documents and like papers flying everywhere. They transcribe this, not this, but reports into their system so that they can make a new payroll customer. Well, all we did is just read the document and put it in the machine. Now, what was the first thing that they did? You would think that they would stand up and say, Glenn, we are so happy, we're so excited. The first thing, this just can't be. It can't work that way. It can't be that easy. Because we're reading the documents at 99.1% accuracy. Even the ones with the arms and the legs and the feet and all that stuff, because we have this way of getting rid of some of that stuff. You say, Glenn, thank you very much. Videos. A lot of people have problem with theft and pillage and things like that. Well, if there's a camera anywhere that's recording anything, we can know that. We're working with one of the utilities that has a lot of coal-fired plants. And they lose about half to 3/4 of the coal that comes off the dock before it gets to the plant. I'm sure it's heating a lot of homes in the local area, right? So I said, Glenn, all we have to do is, they have like thousands of cameras everywhere, but the security guards fall asleep. Or maybe they're paid off or whatever, right? So we have this ability to look at things that have never been looked at before, whether it's pages, whether it's videos, whether it's whatever. And then we do this thing where we mash data up. So in a lot of clinics or pharmacies or retailers, one of the problems is they run out of stuff all the time, right? Because you wouldn't think in this age of computerization and statistics and AI that people would still order 12% more than what they ordered last year in the same months or quarters. But Walmart, the largest retailer on the planet, still does that way across 2.5 million SKUs. It's crazy. And they still have stock outs and overstock, whatever. But for clinics that need medicine, when people get sick, it's not like I can't get Pop-Tarts at Walmart. It's I need life-saving medicine in that place. So one of the things we do is we ingest clinical records about who's been getting sick. We compare it with weather patterns because there is a high correlation between weather and illness, right? We have all those correlations because we own a weather company and a health business, and then we mash it up and we help people understand what medicine to order when, not based on what happened last year, but what the drivers were that might not be normal to the human eye, right? So this combination of vision, looking at what's in the documents, and this aggregation of weather, right? It's a pretty profound thing, very, very exciting. So for one of the largest farming companies in the world, Yara, they wanted to get away from selling seeds and fertilizer. They wanted to actually help farmers grow crops. So we're actually building them a digital farm. Glenn, thank you very much. What's your digital farm? Well, we know the local weather down to the acre that it is. And we also, from space, with a satellite, can watch plants grow. And we can see bugs on the leaves of plants. So if you take computer vision, you watch the plants grow, you watch the bugs on the plants, and you know within the acre what's happening, you can tell them when to water, what organic or other fertilizers to use. You said, Glenn, look, again, that's fine for Phoenix, Arizona, or Paris, France, or London. Well, you know the surprising thing? There's 300 farmers in South Africa that took this up in the last 30 days. They were the highest take-up rate of anybody. Probably because they didn't have that. Remember back where I said about the people thinking, that, oh, this can't work? They just started it, right? So basically, whatever you could imagine with your eyes, what you can hear with your ears, we can interpret. Now, here's the goofy part. When you weld something, for the longest time, we tried to watch people weld and test the nature of the weld. What we found was that wasn't as efficacious as listening to the way the weld sounded. So we don't care what you have, whether you have vision, whether you have documents, whether you have videos, whatever, we can make all that data available so you can make decisions on it. Now, remember that bottom layer, the hybrid cloud? We make all that stuff available to you so you can buy it by the drink. There isn't a $50 or $100 million check you need to write before it works. All that stuff is available right now in simple, easy-to-use APIs that you can pull in. So we wanted to try and show you something that was a little bit further out, and because we believe this is the way things are going to go in the future. For those folks that are working in countries that might not be as advanced, one of the things that IBM has done pretty successfully is we've launched this P-Tech program, where we send kids through high school and a couple of years of vocational school, and then they come and get a job at IBM. There's 106,000 kids that we're bringing through that program because there's not enough people to do this. We can't make enough PhD decision scientists on the planet to deal with the transformation that's about ready to occur in our lives. That's why we're doing it. And for the executive team that I'm a part of, we get together once a year, and they bring some of those P-Tech kids in and have them talk to us so we don't get our heinies all big about ourselves. And those are the lives that I care about touching and transforming, right? Those kids that came from really, really rough backgrounds, and they fundamentally have transformed their lives. So that's our story. We're sticking to it. We're in and out in 30 minutes. I'll take questions. Guys, any questions at all? Please.
Fascinating. Thank you very much. Machine vision, how does it do with handwritten documents?
Yeah, I don't know if you guys could hear. I won't use the adjectives, but he said the program was okay. But he asked about, thank you, by the way. He said, how does it deal with handwriting? So we are not going to read handwriting at 99.1%. We can generally get handwriting that's legible, not mine, in the high 60s to 70s. And just to make sure, 90% were past the accuracy of a PhD, right? In the 70s, we're in the accuracy of most high school and early college kids, that if they were reading it. So we feel pretty good about handwriting. It all just depends upon the quality of the delineation of it. We struggle a little bit with doctors on handwriting because normally with doctors, their brains move faster than the hand can write. That's what my wife kindly tells me is my problem. Well, she says some other things too. But the one thing that we spend a lot of time on for folks in the field is that we're actually able to, if people can just talk to us, we can transcribe all of that, right? So one of the, especially with a lot of the oil rig platforms and folks that are working in extreme conditions where they have gloves and helmets and whatever, Apple said, oh, they just need an iPad. It's like, well, what the hell are you going to do with an iPad? You're going to use your nose to key it in? So we make it so that pretty much if you can talk, we can generally get most all languages at high 80 or 90% accuracy. Hope that helps. Other questions? Please. Has there been any follow-up with the farmers in South Africa about whether the damn thing works or not, right? No. No, I'm kidding. No, I'm sorry. Yara just launched in South Africa about 30 days ago. So we have to go through a planting season, right? But we were, quite honestly, I was astounded at the take-up, right? When you think about 300,000 people in the space of 30 days, just interested in the concept, right? Given the test runs that we've done, we think we'll see crop yields in some countries up probably 40 to 50%. And we can. And the question was, can you attribute that to your WYSI space thing? That's a great question, because whenever you're dealing with things that grow, you could argue that it's all in the Lord's hands and based on the weather patterns and the this and the that, right? That's the hardest thing about testing an AI asset, right? Is to know how to isolate all the non-causal correlative events that occur. So we do our best to isolate all that stuff and identify, oh yeah, well I wasn't going to use this fertilizer, but now the Yara thing told me to do it, so I'm going to try it, right? We think. Now, that's not true for massive commercial farms in Monett, Missouri that have digitized all their tractors and, they're actually, a lot of the commercial farms are actually information technology businesses that happen to grow crops, right? We probably won't get 50% there, but in a lot of other spots, we're pretty excited about it. And then, I know you didn't ask me this question, but you made me think about something else. You're going to say, damn, I'm not going to ask this guy a question again. But you've seen all the blockchain commercials, right, that we do on TV? Blockchain said, the whole brand promise of blockchain is, I can tell you from the seed in the soil the efficacy of the plant that came out, right? So for these farmers, we're going to attach blockchain to it so they can certify the efficacy of their stuff, and they could go global with their crops, because a lot of the farmers that aren't commercial farms, they don't use all that crap that nobody wants. They're just using good, wholesome stuff that people would pay for if they knew about it and they could certify it, right? So Yara plans on introducing that concept of blockchain organic certification to drive a global presence from a number of the farmers. I'm really bought off on the whole Yara thing, because I would love to see some of those small local farmers really get a boost based on some of the practices they practice.
Yep, absolutely.
Yes?
Thank you. Hi, great presentation.
Thanks.
So question, in the panel, one of the panelists discussed how her organization is oftentimes a little bit hesitant to adapt these new technologies, especially when people's lives are at risk. How does IBM manipulate their technologies and so forth when certain organizations or countries as a whole may not have the infrastructure or know-how to support such advanced tech? Yeah.
That's a great question. One of the many things that makes me proud to be an IBMer, from 2017 we started publishing these concepts of ethical AI and just how far we'd let a machine make a decision. And I recommend you go to the IBM website and look at those things, because I'll never forget when Ginny was wanting to publish it. I'm like, well, nobody's going to care about that. Well, all of a sudden everybody cares about it now, right? So there is a line that we will not cross, right? And all of these assets are designed to augment and enhance the human experience, but we want a human being to be the final arbitrator of the decisions that are made. Now, especially when we're dealing with pharma and medicine, right? First of all, like me, if you tell me what to do, I will resist you. It's just, I pray every day that the Lord would change that in me, but doctors is that same way. Think about it. You spend 8 years, 10 years getting your license to practice medicine, and here's a machine that's going to tell you how to do it better. No, right? The doctor says, no, you're full of it, I won't listen to you. We want that doctor making the final decision, but we want to bring to them all of the fact patterns to make the single best decision they could make based on the medical journals or clinical trials that just came out. Right? So that's what we're trying to do, is enhance, but allow the human being to make the final decision. Please, one last question. All right, guys, thank you very much. Have a great afternoon, and we'll see you soon. Thanks.